In today's class, we will discuss the effect of neutral in a three-phase system. So if you take a three-phase system, we have both three-phase three-wire system as well as three-phase four-wire system. So the fourth wire will be the neutral wire. So in this derivation, we are going to prove that the zero sequence currents will flow through the neutral wire, and if there is no neutral wire, the zero sequence currents will be equal to 0. Okay. So let us consider a star connected system as shown in the diagram. So A, B, C is the sequence taken. IA, IB and IC are the incoming currents to the star connected system. Okay. So we have the neutral wire connected to the star point. So since the current directions, line currents are in this direction, it is going inside the system, the neutral current will be away from the neutral point. So to differentiate a three-phase three-wire system and a three-phase four-wire system, we have provided a switch S in the neutral wire. Okay, so if the switch S is open, there is no neutral wire, it becomes three-phase three-wire. If the switch is closed, it is a three-phase four-wire system. So let us consider IA, IB, IC as the unbalanced line currents. So why we are considering IA, IB, IC as the unbalanced line currents means only when the system is unbalanced, the unbalanced current will flow through the neutral wire as the zero sequence currents. Okay. So case 1, four-wire system. Current IN flows through the neutral wire as I told already. So IN is the summation of the other three line currents. IA plus IB plus IC, and already we have the phase values of currents in terms of its symmetrical components. IA is IA0 plus IA1 plus IA2, IB is IA0 plus A square IA1 plus A IA2, and IC is IA0 plus A IA1 plus A square IA2. Okay, so this derivation we have done in the initial classes. So substitute the values of IA, IB, IC in IN. So when you add everything and group the terms IA0, 3 IA0 plus IA1 into 1 plus A square plus A. So we know 1 plus A square is equal to 0. Similarly, group IA2 terms. IA2 into 1 plus A square. So again, IA2 term is also equal to 0. Okay, so we get IN is equal to 3 IA0. Okay, so in the case of an unbalanced three-phase four-wire system, the zero sequence current 3 into IA0 flows through the neutral wire. Okay. So coming to case 2, three-wire system, the switch S is open. So there is no neutral current, IN is equal to 0. So IA plus IB plus IC equal to 0. Okay. Again substitute for IA, IB, IC in terms of the symmetrical components. And grouping IA0, IA1 and IA2 together, you will see that 1 plus A square is 0. So 3 IA0 is equal to 0 and IA0 is equal to 0. So what do we infer from this? Zero sequence currents are absent in a three-wire system. Zero sequence currents are absent in a three-wire system. Okay. So the unbalanced currents will flow through the neutral wire. So in the case of a four-wire system, 3 IA0 flows through the neutral wire. In the case of a three-wire system, IA0 will be equal to 0 since IN is equal to 0. So next one is a small derivation, a small proof. Prove that a three-phase symmetrically wound alternator generates only positive sequence components of voltages. Prove that a three-phase symmetrically wound alternator generates only positive sequence components of voltages. Okay. So again we are considering a three-phase alternator. A, B, C are the three phases. EA, EB, EC are the induced EMFs in the three phases. And we are following ABC phase sequence. Okay. So since the windings are symmetrical, the induced EMFs will be balanced. Okay. So we have the same voltage applied across each phase, and we have similar number of same number of turns and similar windings in the three phases. So it is called as a symmetrical, and the induced EMFs also will be balanced. Okay. So we know the magnitude will be the same and it has an ABC sequence, and the phase angle between the three EMFs will be 120 degree from each other. Okay. So let us consider the magnitude of the induced EMFs EA equal to EB is equal to EC is equal to EP. Okay. So phase voltage EP. So taking ABC sequence, we can write EA is equal to magnitude of EA, which is EP, angle 0. We have taken EA as the reference. So with respect to EA, EB is EP angle minus 120 or EP angle 240. EC is equal to EP angle 120 or EP angle minus 240. Okay. So this we have written so many times. So now the sequence components of voltages are found. Okay. So the sequence components of the induced EMFs EA0, zero sequence component is equal to 1 by 3 EA plus EB plus EC. Okay. So this equations are taken from the derivation for writing the sequence components, symmetrical components in terms of the phase voltages. Okay. So substitute for EA, substitute for EB and EC. Okay. And what is EP angle minus 120? It is EP cos of minus 120 plus J sin minus 120. The same way, write EP angle 120, which is in polar form, in write in the form of rectangular form. Cos of 120 plus J sin 120. Substitute the values. Cos minus 120 is minus 0.5. Sin minus 120 is minus J 0.866. Cos 120 minus 0.5. Sin 120 plus J 0.866. Okay. So multiply, cancel out the terms. You will get EA0 is equal to 0. So what do you infer from here? The zero sequence component of the induced EMF is 0 in the case of a symmetrical circuit generator, alternator. So positive sequence current, EMF, EA1 is equal to 1 by 3 into EA plus AEB plus A square EC. So what is A? 1 angle 120. What is A square? 1 angle 240. Okay. Substitute for AEB EC. Write it in terms of rectangular form and get the answer for EA1. So you will get EA1 as EP. You will get EA1 as EP. The same way, negative sequence component EA2 is equal to 1 by 3 EA plus A square EB plus AEC. A square we know, A we know, EB, EC, EA, everything to be substituted. Simplify, expand, write it in rectangular form, expand, cancel out the possible terms, you will get EA2 is equal to 0. So what did you infer? We have found that zero sequence component of induced EMF is 0. Negative sequence component of induced EMF is 0. So we have only positive sequence component EA1 is equal to EP. Okay. So we have proved that three-phase symmetrically wound alternator can generate only positive sequence components of voltages. Okay. So this is the reason why in the case of drawing sequence networks, remember in positive sequence network alone we are showing the induced EMF EG. Okay. In the case of negative sequence networks we remove EG because there is no sequence components for negative sequence components of the voltages. Okay. And zero sequence component also we are not showing the, in zero sequence network also we are not showing the EMF. Okay.